Alright, I'm Cesar Torres. I'm going to teach you how to derive a function. Now, what is deriving a function? Basically, it's finding the rate of change of a function, such as 5 of x. If you derived it, you get 5x, or you just get 5. And if you did it again, you would get the rate of change of that rate of change, or a slope of a slope, which would just be 0, since it has no x value. Now, what is this useful for? This is useful because it tells you about basically the rate of change of a function and how it's supposed to look. So if I were to have like, say a graph, it would just tell me the rate of change of that graph without it like, whether or not it changes depending on how it swerves. And you could probably get something like this. And the best part about deriving something, you could have something like a And you have different techniques that you could use, such as quotient rule, product rule, and also chain rule. And basically for either of these, they use different properties that you use in regular math, such as division, multiplication, and exponents. So if I had a function right here, such as 2x minus 1 to the exponent of 3, if you're going to derive a function with an exponent, you'd have to move that right there. So it'd be 3 over 2x minus 1. And you'd also have to derive the function inside. You subtract 1 from here, by the way. And then you also have to subtract 1, subtract 1 from there, and then you have to derive what's inside here. So this is a constant, so it goes to 0. And this is 2x, so it just goes down to 2. And then you multiply these two together. So you have, after you subtract this, you would have to derive the function here to get 2. And also, since you have 2 right here, you have to multiply it to the front. So you get 6, 2x minus 1 squared. Now for the product rule, you would have to get like 2x multiplied by something like 1x. And in order to do the product rule, you would have to derive 1, so you get 2, and then let me just put that x, and then not derive 1, plus the other way around. So you don't derive this one, but you derive the other one to get what you would usually get. So you get 2x plus 2x. So for the product rule, you would get 4x right here. And finally, you would also have quotient rule. Quotient rule is kind of hard, but also you get used to it, and it's really useful. It's basically division. So I'll have 2x right here and then 1x right there. Now for quotient rule, you would have to, it's kind of weird. You gotta like you have to have this be the same, so it'd be 2x multiplied by this derived. So you'd have 1 right here. And then subtract it from 2, which you derived, and then just regular 1x right there. And since it's a quotient rule, you would also need to have, you'd have to have the function down here to the power of like 2. And after you have that, you have to multiply these. 2x minus 2x over 1x squared. 1x squared. Now with that, you would have to, you would solve for this, so it would be 0 over 1x squared, which is an impossible function, which you can, after you do that, you have to multiply, and then after you solve for both, you would have to subtract both of them. Typically you'd have to, but I'm just going to show you what could happen, because some of these product rules may have problems, such as you might have like a function given to you where you have 0 on top, and that is a function that is impossible to get. You cannot solve it by deriving it. Thank you for watching my video, and I hope you enjoyed.